This video is the next video in the trigonometry set of videos. In particular, this is looking at section 6 of the trigonometry notes, which is based on the sine rule. One key thing to remember when you're working with trigonometry or you're working with triangles, that Pythagoras' theorem, so c squared is equal to a squared plus b squared, and SOHCAHTOA, so sine, cos and tan ratios, they only work with right angle triangles, so triangles that have the 90-degree angle in it. However, in many questions and in many exams, you'll be given triangles that don't have a 90-degree angle. So you could be given another type of isosceles or a scalene triangle, or you could be given an equilateral triangle, and you could be asked to find the length of a side or an angle of that triangle. So we can't use Pythagoras' theorem or we can't use SOHCAHTOA, so we use another type of rule, which is called the sine rule, and this will work for triangles that are right angled and non-right angled triangles, and it's given in the formula tables booklet on page 16, so you don't have to learn it off by heart. And this is the formula that we use. So a over sine of a is equal to b over sine of b is equal to c over sine of c. Above it is what you would see in the formula and tables booklet on page 16 as well. They give you a triangle that is a non-right angle triangle, and again we label the sides. So if we have small a on one side, capital A is the angle that's opposite the small a side. It's the same with b, so we have here capital B, that is the angle that's opposite the side B. And finally we have capital C, and that is opposite the side that is lowercase c. When you're answering questions in trigonometry, you're either asked to find the side of a triangle, so that would be the first one, or the angle. So it's either the side of a triangle or we're looking for the angle of a triangle. Then, to find the side, what you need is you need one other side and two other angles. So to find the side of a triangle using the sine rule, you need one other side of that triangle and you need two other angles of that triangle. To find an angle using the sine rule, you need at least one other angle and two other sides. Just to recap that one more time then, if we want to find a side of a triangle, and it's a question they ask the whole time, we've seen it already using right angle triangles, they would ask you to find the side of the triangle. If you need to find the side of a triangle using the sine rule, you need one other side and you need two other angles. To find an angle using the sine rule, we need one other angle and two other sides. So we basically need a pair. So in order to use the sine rule, you need a pair. You need to know the length of the side and the size of the angle opposite that. If you don't have that, you cannot use the sine rule. The sine rule is written on page 16 as a over sine of a is equal to b over sine of b is equal to c over sine of v. So you can see here that the sides are on top. Use this way if you're looking to find the side of a triangle. However, the sine rule can also be written with the angles on top. So sine of a over a is equal to sine of b over b, which is equal to sine of c over c. So it's easier to use this way if you're looking for an angle. So there's two ways, and although only one of them is in the formula and tables booklet, you can write it as a over sine of a is equal to b over sine of b is equal to c over sine of c. Or you can rewrite it as sine a over a is equal to sine b over b is equal to sine c over c. And that's what we're going to do. Now, that might not make too much sense at the moment. However, what we're going to do is we're going to do a few examples and it will hopefully make much more sense then. Question 6.1 here, it says, find the size of the angle marked x in the following triangle. Give your answer correct to one decimal place. Now, in this particular question, we're looking at a non-right angle triangle because obviously if this angle here was a right angle, it would need to be 90 degrees. However, if it was 90 degrees, then the total angles in the triangle would add up to more than 180 degrees, which can't be correct. So we can't use Pythagoras' theorem, we can't use SOHCAHTOA, we're going to use then the sine rule. If you can remember from the last page, the sine rule is a over the sine of a is equal to b over the sine of b is equal to c over the sine of c. And that is for when we're looking for a side. When we're looking for an angle, we can write sine of a over a is equal to the sine of b over b is equal to the sine of c over c. I'll actually write that beside it as well because I know it takes a bit of time to remember which one is which. So this is for a side and this is if you're looking for an angle. Question 6.1 then says, find the size of the side marked X in the following triangle. Give your answer correct to one decimal place. What I'm going to do next then is I'm going to label the sides and the angles. The best thing to do is figure out the side that you're looking for. So that side is X in this example. And what you do is you label that one A. So this one is small a. The angle opposite that is capital A. Then we pick the sides that we have next. So we have 6.4, so we'll label that B. And then we'll label the other side capital B, because it's opposite side B. Then we can label the bottom one C, and the angle opposite that capital C. What we're going to do then is we're going to fill in the formula. Now we only need to take one section of it. So we're here looking for a side, so we're going to use the top one. So it's going to be A over the sine of A is equal to B over the sine of B. We can only have one equals to equation in maths, and we're looking at side A. We have side B, so we're going to take A and B, and we fill it in next. So A is X over the sine of 47 is equal to B, which is 6.4, over the sine of 61. Next, I want to get the X by itself, so I'm going to multiply both sides by sine 47. So this will become X by sine 47 over the sine of 47 is equal to 6.4 times the sine of 47, all divided by the sine of 61. What we get here is the sine of 47, and the sine of 47 will just equal 1. So it'll become X is equal to 6.4 sine of 47 over the sine of 61. And when you type that into your calculator, you're going to get that X is equal to 5.351. It wants it correct to one decimal place, so we get that X is equal to 5.4. So that's this question completely finished then. We found what X is using the sine rule. I'm hoping that this makes sense. We're going to go through a few more examples on the next slide. Question 6.2 says, find the length of the side marked X in the following triangle. Give your answer correct to the nearest whole number. So again, we look at this triangle and we can see that it's not a right angle triangle. There's no angle in it that's 90 degrees, so we can't use Pythagoras' theorem or SOHCAHTOA. We're going to use the sine rule. The sine rule comes in two forms. We have A over sine of A is equal to B over sine of B is equal to C over the sine of C, or we can write it as the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. When we have it in the form at the top, we're looking for a side, and when we have it in the form at the bottom, we're looking for an angle. In this question, we're looking for the side. In particular, we're looking for the side marked X. So what I'm going to do is I'm going to start filling in the information. Here we have that X is A. The side opposite that is going to be capital A. Then 13.5 we'll have as B. The side opposite that is capital B. And then we have the last side, which is C, and the angle opposite that, which is capital C. So we need A, so we need to use A. So we're going to write out A over sine of A is equal to B over sine of B. And we need to then fill it in. Now, so we need A, which is X, we're going with that, but we need capital A. We don't have, or they haven't given us capital A, but we're able to work it out. And the reason why we're able to work it out is because they've given us that the other two sides are 59 and 59. We know that there's 180 degrees in a triangle, so we just go 180 degrees, take 59 degrees, take 59 degrees, which will give us an answer of 62. So now we know that A is equal to 62 degrees. Filling in the information we have then, so A is X over the sine of A, and A is 62, so the sine of 62 is equal to B, which is 13.5, over the sine of B, which is the sine of 59. Then we need to multiply both sides by sine 62, so we'll get X sine 62 over sine 62 is equal to 13.5 by sine 62, and that's divided by the sine of 59, When we have the sine 62 and the sine 62 will divide to give us 1, so we'll be left with x is equal to 13.5 times the sine of 62 divided by the sine of 59. So what we're going to get, when we type all of that into the calculator, we'll get an answer of 13.906, and it wants it correct to the nearest whole number, so that's going to be x equals to 14. Now that's this question done. We figured out what x is, we know that it's 14, and that's all they wanted us to do. The last example in this video then is a question 6.3, and this here says find the size of the angle marked x in the following triangle. Give your answer correct to the nearest degree. Again, we look at this triangle. It's not a right angle triangle. It doesn't have a 90-degree angle. So we're not able to use Pythagoras' theorem or SOHCAHTOA. So what we have to use is we have to use the sine rule. We know that the sine rule can be written as a over the sine of a is equal to b over the sine of b is equal to c over the sine of c. It could also be rewritten as the sine of a over a is equal to the sine of b over b is equal to the sine of c over c. Again, we know that when we have it written like this, we can find the side, and when we have it written like this, we can find an angle. Here it says find the size of the angle marked x in the following triangle. Give your answer correct to the nearest degree. What we're going to do here is we're going to start filling in or labeling the sides and the angles. So we're looking for the angle marked x, so we're going to label that capital A. So the side opposite that is going to be A. Then we can label the other angles, so this would be B, this would be C, this would be small b, and this would be small c. We're looking for an angle in this question, so we're going to use the angle way of representing the sine rule. So it's sine of a over a is equal to the sine of b over b. Here then we can start filling it in. So we have the sine of x over 4.5 is equal to the sine of 72 over 6. We need the sine of x to be by itself, so we're going to multiply both sides by 4.5. It'll become the sine of x times 4.5 over 4.5 is equal to the sine of 72 times 4.5 over 6. 4.5 divided by 4.5 will give us 1, so we'll be left with the sine of x is equal to the sine of 72 multiplied by 4.5, and all of that is divided by 6. Finally then, we need to get the x by itself, so we're going to get the sine inverse of the right hand side, which is the sine of 72 times 4.5 all over 6. When we type that into our calculator, we're going to get that x is equal to 45.503, and it wants it correct to the nearest degree, so it's going to be x is equal to 46 degrees. That's this question finished then. All they wanted us to do was find the angle marked x. We've done that using the sine rule, so we're completely finished. That then brings this video to an end. We've had 2 examples of the sine rule when we're trying to find a side, and we've had 1 example of a sine rule when we're trying to find the angle. What you're going to do now is you're going to answer a few questions on these rules, making sure that you're comfortable with using it to find an angle and using it to find a side, and then we'll be looking at more real-life applications. If there's any problems in relation to this, just get in touch with me and I'll try and answer them as soon as possible.